Yeah.
Okay, so here's just a really quick video to help you with net ionic equations. And I'm going to start by referring to the demo that we did the other day, which was lead nitrate and potassium iodide making lead iodide and potassium nitrate. You balance, there's a 2 there and a 2 there. And if you remember, the reactants were both soluble. And we know this should be soluble because there's nitrate. And we know this is soluble because it has potassium. But we also just looked at the reactants and they were see-through, nice, clear solutions. Then when we put them together, we got a really bright yellow solid. And we knew it was a solid because we couldn't see through it anymore. So the question is, which of these two do we think was the bright yellow solid? Well, if we look at this, it has an alkali metal and nitrate, so this really should be soluble. We really don't know anything about lead solubility or iodide solubility, but because it's not this, by process of elimination, that has to be the solid. Okay, that's fine and good. How does that relate to a net ionic equation? Well, I'm just going to ask you, what's the good stuff here? This is kind of boring, this is kind of boring, that's kind of boring, but this is really cool. And where did the lead to make lead iodide come from? It came from here. Where did the iodine to make the lead iodide come from? It came from here. So now let's backtrack a little bit. We really want an equation, really, it's lead and iodine make lead iodide. That's really what we're after. So how does that kind of look? Well, let's go back and ask ourselves, if lead nitrate is aqueous, if we kind of imagine that we're on a magic school bus ride and we can jump into the beaker and look at the molecules, kind of a particulate view, what would this actually look like? Would it be a big molecule, or would it actually be ions broken apart? And a lot of you are remembering that that is the way ionic compounds dissolve. They break apart into ions. This does the same thing. So you have some potassium ions and some iodide ions. This stayed together. That's why it was solid and that bright yellow, non-see-through stuff. This is also an ionic compound, so it would break up into ions. So again, it's these lead ions and these iodide ions that are making the cool thing. So the essence of the reaction, what really happened was that lead ions ran into iodide ions, they stuck together and they formed lead iodide. This is the essence of what happened, and for that reason we call this the net ionic equation, NIE. And that's what you're going to be learning to write. You're going to be learning to focus on the things that really changed and how to write a net ionic equation. And one more thing I want to mention is, so what's up with the boring things? Do you see that nitrate stayed as nitrate? Potassium stayed as potassium? There was no real change. So we say that these really didn't participate in the reaction. They were just kind of hanging out watching. We call them spectator ions. And notice we did not include them in the net ionic equation. Anytime you have an ion or any kind of species that stays exactly the same, you cross it out. Kind of like in math, if you have a 2x on one side and a 2x on the other, you can cancel it out. And so notice what's left is exactly what we wrote before.